So I was messing around in PowerPoint and apparently it's got this as an optional background. So this is what we're going to use for the big M method. It's not as bad as two-stage. It's pretty bad, but it's not as bad. Let's go. Okay, so this is our big M method. We're going to solve our objective function or maximize our objective function subject to our three inequalities. So the first step is the same as what you've been doing. It's going to introduce slack, surplus, and artificial variables just like before. So our first inequality would go to x plus y plus 2z, and 2 kind of looks like a z, plus 2z plus, let's say, r is equal to 10. Our second inequality is going to go to 2x minus 3y plus z, and then we need to subtract the surplus variable and add the artificial variable, so that's 5. And then our third one, x plus y, subtract the slack, the surplus, add the artificial, and we'll get that equal to 8. So that's step 1. Step 2 is that for every artificial variable, so we've got 2 of them here, we've got a and b, we're going to need to subtract from the objective function ma. So we're essentially saying here that p is equal to 3x minus 2y plus z, because that's what they are. Take away m lots of a plus b. Reason for this is so we're taking m to be a really massive number, and we know that a feasible solution exists if the artificial variables are both 0. So we want to do a simplex essentially that's going to maximize this new objective function, and because m is so massive and will be such an overbearing part of this equation, this will be maximized if we can make a plus b equal to 0. Because if it's any other value, the m will dominate, and as it's being subtracted, it'll make it incredibly negative. So when we maximize, we'll get a plus b to be 0 because m is so big. That's the theory. I think if this is on a computer, they'd probably take like whatever the biggest value is on the spreadsheet and times it by 100 and set that to be m or something, but we're essentially treating it as infinite. So we've done that. Then we're going to need to do the same thing we did on two-stage and remove that sum of artificial variables. So we're going to need to work out a plus b in terms of other variables. So we'll take, the second and third equations that we've worked out up here, and we'll rearrange them to be a and b. So the first equation is 5 minus 2x plus 3y minus z plus s. Yep. And then the second equation is plus 8 minus x minus y plus t. Okay. And we can tidy that up to be 13 minus 3x plus 2y. Let me just double check. Yeah, that makes sense. Minus z plus s plus t. That's our value of a. So we're now going to substitute that into our equation. We're going to say we've got p is 3x minus 2y plus z minus m lots of 13 minus 3x plus 2y minus z plus s plus t. And our next step would obviously be to sort of expand this and simplify it as much as we can, but we have substituted. So we'll go to, I'm going to need more space here, p is 3x minus 2y plus z minus 13m minus 3xm. And well, you get the idea. And then the last thing we want to do to make this easy, well, second to last thing, is collect our variables together. So there's some mistakes I've made there, isn't there? So my signs, I've got to bear in fact that I am multiplying by minus m. I'm not just multiplying by m. So it's going to be not just minus 13m, sorry, it's going to be plus 3xm minus 2ym plus zm minus sm minus tm. Okay, so the next thing we're going to do at that stage is then collect our terms together. So that means in terms of taking out factors of x, so we're going to have 3 plus 3x lots of 3 plus 3m lots of x. We're going to have, and I'm going to have these all as pluses because it'll make my life a bit easier, I think. Minus 2 minus 2m lots of y. Yeah, okay, so that's dealt with these two and these two. Then we're going to have plus 1 plus m lots of z, which will deal with these two. Then we're going to have minus sm minus tm minus 13m. So that's dealt with those three. So yeah, we're good. And then finally, we're going to need to rearrange that obviously to make, I guess, all the algebra appear on one side. So we're going to have p, and then it would be tempting to write minus this thing, but I found it was way easier if I just said plus every time. So plus minus 3 minus 3m lots of x, plus 2 plus 2m lots of y. So we changed the signs. It's because we changed the sides. Plus minus 1 minus m lots of z, plus sm plus tm equals minus 13m. Blimey. So we define this like quite awkward objective function, but it means that we don't have to do the thing where we found I as being the sum of the artificials and minimizing that. So what's our last step is we're going to apply a normal simplex method. So our three equations, we've obviously got the p plus that. We've got our x plus y plus 2z plus r equals 10. We've got our 2x minus 3y plus z minus s plus a equals 5. And we've got our x plus y minus t plus b equals 8. And we're going to take those four equations and we're going to substitute them into our spreadsheet. Okie dokie, so we copy pasted that across. It'll make it a lot easier if I can read them. And we're just going to treat this as a normal simplex. Now the question doesn't say, you know, solve the problem. It just says set up the initial tableau, carry out one iteration, find the value of the variables at that stage, and explain why this solution is not feasible. And this is more common or typical, I suppose, of what an exam question would do. It's not going to get you to run through 5 iterations when they don't want to give you 55 marks, I suppose, for one question. Okay, so let's start. Our base variables are going to be p, r, a, and b, because there's one of them in each equation, and it's the values that we're assuming at the start. So we've also got our values as being minus 13. So let's fill this in. So p column, I think this might be the last time we see it, but it's just going to be 1, and z everywhere else. And you may need to write on a diagonal or use your extra small writing, but this is minus 3 minus 3m. This is 2 plus 2m. This is minus 1 minus m. And then the rest of them get a little bit easier. So we've got no r's. We've got m, lots of s. We've got m, lots of t. No a's, no b's. And minus 13m as our value. And that's our equation 1. Suppose I could label up my equation straight away. And then we'll do the same for the other ones. So we've got x, y, 2z, r is equal to 10. And we've got 2x minus 3y plus z minus s plus a equals 5. I don't know why I'm writing equals in there. Should be 0. And then we've got x, y, no z, no r, no s, minus t plus b is equal to 8. Okay, so that is our initial table. And what we said here is we're going to carry out one iteration on this tableau. So let's do that. First thing we need to decide is where our pivot is. Now we've recently switched to saying that we choose the pivot on the column with the most massive number on top. And in this case, that is definitely minus 3m, because m is obviously massive, so minus 3m is bigger than minus 1m. So it's that column, and then we just need to actually do the calculation. So for our pivot choice, we're doing 10 divided by 1, we're doing 5 divided by 2, and we're doing 8 divided by 1. And the biggest of, smallest of those, because we want to minimize that, is obviously our 5 divided by 2. So that's our pivot point there. So that means that our first row, that's going to change the base variable to x, and the other ones will be unchanged, is going to be row 3 and then divided by 2. So let's do that. We'll get 0, 1, minus 3 over 2, a half, 0, minus a half. Well, you get the idea. Now, the row 6 and row 8 are fairly straightforward to get. So that's because they've just got ones in the column that we want. And so all we need to do is say that we want to do row 2 and we want to subtract from it row 7. And we're going to do the same for row 8 and subtract row 7. Now I'm not going to run through that in real time. I'm just going to fill those in and we'll come back when I've done. Okie dokie, so those are the values we should have got. Now one I seem to remember people having to be careful about was this 5 over 2 because you're subtracting a minus, you're actually adding 3 over 2 rather than taking away 3 over 2. We'll have a check, make sure that you're happy with those, and then let's address the elephant in the room, this P row. So what's that going to be equal to? Well, obviously it's going to be equal to row 1, and then we're going to have to add 3 plus 3m lots of row 7 to this. And that's a fairly daunting prospect in terms of trying to do that all in your head. So this is what I did. I worked out what 3 plus 3m lots of row 7 was first, and you can obviously just do this somewhere on the side, but it just felt like a much easier way of dealing with things. So I want to take obviously this row and I want to times it by 3 plus 3m. So that will give me 0, that'll give me 3 plus 3m, that'll give me minus 9 over 2 minus 9 over 2m. You get the idea. So don't forget to times by 3, 3 over 2 plus 3 over 2m, 0 again, minus 3 over 2 minus 3 over 2m, 0 again, 3 over 2 plus 3 over 2m, 0 again, and then what's that going to be? 15 over 2 plus 15 over 2m. Okay, quick check. Yeah, that looks all in order. And what we're going to need to do is add that now to row 1. So you kind of want to put your fingers on row 1 and this extra row that you've created and sum them together. So we're going to end up with a 1 obviously in the P row, a 0 in the pivot column because we should. And then what about our next one? Well, our next one we're going to have to do 2 take away 9 over 2. So that's minus 5 over 2. And 2m take away 9 over 2m. So that's going to be take away minus 5 over 2m. And then the rest of it, obviously I don't want to talk through these all individually. You know what you need to do from there. You need to add our blue row there to our row 1. I'll fill in the rest of the values. And there we go. That's what we should have got at the end of all that. And obviously this looks horrendous. And if we were to run through the entire process, this would take ages. But luckily the question is not asking us for that. The question is saying, set up the initial tableau, which we did up here. Carry out one iteration, which we've done, and then to find the value of each variable at that stage. So at that particular stage, we can say that P is equal to 15 over 2 minus 11 over 2m. So P is unspeakably negative. We can say that R is 15 over 2. We can say that X is 5 over 2. And we can say that B is 11 over 2. And all other variables, so what have we got? We've had X, so Y and Z and S and T and A, they're all equal to 0 at this stage. So we've done that, and then it says find the value of each variable at stage. We've done and explain why the solution is not feasible. So the reason the solution is not feasible is that the artificial variables still have values. That's definitely one way we could say it. We're not saying it can't be solved. We're not saying no feasible solution exists, but this is not a feasible solution because the artificial variables have a positive value. So artificial variables are non-zero would be a succinct way of saying that. Okay, so that's the basic idea behind Big M. What we're going to do is we're going to run through the start of using it to solve a full problem, and homework's going to be to finish that off. So let's see the problem. So here are our initial constraints. I think you do know what you're doing with these now. We're going to set up P is equal to x minus y plus z take away ma. Well, actually, we need to figure out how many artificial variables we've got first. Take away m lots of something. We're going to change this to 2x plus y plus z plus, let's go with r, is equal to 20. We've got x minus 2y minus z plus s is equal to 7. And we've got x minus, minus t, and then plus our artificial variable, which I guess we'll call a, is equal to 4. And so, yeah, our objective function needs to look like that. So have a go at trying to fix up your objective function into the correct form, and unpause when you're ready to check that you got the right thing. I will say for me, the thing I always forget is the fact I'm subtracting m, so I forget to change the signs here and make this into plus mx. I don't know if that is just me though. Alright, let's keep going. So there we put them roughly into the order that they need to be when we're going to put them in the tableau. And then let's sort of finish this off. We want to put all of the algebra on one side. So let's get rid of this. And let's say that we've got p plus, and it'll be minus 1 minus m lots of x plus y minus z plus mt is equal to minus 4m. So there are our 4 equations we're going to start with. So let's plug them in a formula into the tableau. Okay, so the first job is obviously to put stuff in the tableau. I'm just going to do that through pause magic. Hang on. There we go, pause magic. Then we're going to need to choose our pivot row. So which is the most massive column? It's going to be this one here. We've got minus 1 minus m. That's definitely bigger than anything apart from minus 4m. And you can't use the value column to do this. So what do we want to pivot on? Well, we should do our calculations. So 20 divided by 2, and 7 divided by 1, and 4 divided by 1. And the smallest of those is obviously the 4 divided by 1. So we're going to pivot on this value here. Okay. So how do we want to set this out? Now I could just say pop forward a little bit in the future, but I think we will kind of show this first iteration fully. And you can obviously speed it up if you need to. So the good thing about that is it's got a 1 in the pivot row already, so we don't need to change that pivot row at all. Obviously the base variable becomes x. We've got PRS and x. And then otherwise this is exactly the same. And it's also a value that will be easy to add to other things. Now if we want to write down the other equations, let's start from the bottom. So row 7 is going to be row 3, but take that away. So we're going to need to subtract row 8, or we could even subtract row 4 from it, to be honest, wouldn't make a difference. For 6, we're going to take away 2 lots of row 8, or 2 lots of row 4 if you want. And then for the other one, we're going to need to add 1 plus m lots of row 8. Now I found it helpful to actually rewrite that. Instead of saying 1 plus m in a bracket, I'm saying I'm adding row 8 and then I'm adding m more lots of row 8. But you know, if you want to say row 1 plus 1 plus m lots of row 8, I'm not going to stop you, and that might make more sense to you. Okie dokie. So what I think I will do quickly is fill in row 6 and 7, and then we'll talk through the top row. So there's the S row, there's row 7, and there's row R, the 6th row. So just be careful on signs and that. There's nothing else that's particularly scary that you haven't seen 1,000 times before. Let's talk pivot row. So we know the pivot column is going to be all zeros, so we don't need to work anything out there. We're going to take row 1, we're going to add row 8 to it, and then we're going to add m lots of row 8 to it. And in most cases this is not going to change anything because we've got this big row of zeros here, and that's not going to alter anything, so we can just fill in immediately 1 minus 1, 0, 0. Then we've got to actually do something. So to m in the t column, we're going to add minus 1, and then we're going to add minus 1 lots of m. So we're going to do m minus 1 minus m. Luckily, that exactly cancels out to just give us minus 1, so we've got rid of something already. Excellent. However, our victory is short-lived, as in the A column, we start with 0 and we add 1 plus m lots of 1. So we're going to add 1 plus m to that column. Finally, for the bottom one, we're going to need to add 4, and we're going to need to add 4 lots of m. That will cancel out with our minus 4m, so that'll just leave us with 4. So that was what I would describe as a good iteration. It got rid of a lot of the m's that we have to think about. Okay, so that's the first iteration, and then all I want you to do is I want you to complete this iteration. I will point out there are 3 more iterations to go, and then at the end of that, can you just say what the values are, and it should match up to something we've already done. Okay, cool. Any questions? Let me know.